It's a great idea. All right, phones away. Second, Sam. No phones out. Last lesson of probability. I know you guys have been thoroughly enjoying probability. I could see it in your face. This is the last lesson on probability. Then we're going to get into geometry after this one. Okay, so here's the last one. You have a little, what we call a Venn diagram handout I just gave you. You're going to mark it up with notes right now. I have 4 Venn diagrams on my board that are not, they're not spread out the way yours are. Okay, yours is 2 on top, 2 on the bottom, but I'm going to go one at a time. You're going to just, on any empty space, this is for you to keep. It's a note guide. Follow along. You guys remember the 2 categories from yesterday we did for our class? Hold up. U.S. soccer. Going to put U.S. soccer here. No, U.S. football. I need more coffee, sorry.
Wait, but why you put U.S. soccer?
U.S. football.
Oh, it's like...
You need more coffee, too. Never mind. Thank you. All right, Simon, you had a question.
I was just going to ask you if you could write on the other side of the board.
Got you. Or there's about 50,000 desks you can move just for the lecture. Just a thought. Well, I'll move for you. I got you. I got you. And here's soccer. What was that category? Now, if I asked you, what's the probability of a student? Here we go. I need it. Burns, I'm talking now. No more talking. I got the floor. You're the man. Okay, still. No more talking, gentlemen. Thank you. The probability of, watch this now, of a student in here or a human being in here liking football and liking soccer, we're going to put P, parentheses, F and S. Actually, not F and S. Yeah, F and S in here. Football and liking soccer would be, go ahead and shade in between the 2 circles. Thanks. Gracias. So far, so good. Okay, so shade that in. Speak for yourself. Ready? How about the probability of someone liking football only? What would I shade? The whole circle? The whole circle? Let me do the. Here we go.
Second one like that?
There it is. Football only.
We do the second one like that?
Yeah, so do your second one like that. But put this next to your picture. Right, Ramirez? Got you. All right, I got the notes. Hurry up, quick. First 2. Already shaded in. Quick. You're the man, Rodriguez. You actually picked up the pencil. That's awesome. Let's do it. Hold on. Hold up, so how about this one? Yeah, the second one. The third one. How about the probability? Hold up here. How about the probability now of not football or soccer?
Outside.
Where? Exactly. Go ahead and shade this in. Burns, relax, man. I saw the floor. There it is. Whatever's outside the 2 categories is what's not those 2 categories. Think logically here. Think logically with me for a minute. I know it hurts for some of you. gonna be okay though. Yeah. You want? It sounds like you want me to hear you. You like salivating. Feelings are notoriously unreliable to detect truth.
That's what I'm asking you.
Yeah. What,
You see what I mean? I'm asking you. That's how it sounds.
Hold on, we'll talk about our hatred of you after the news.
so you do have hatred.
Our potential.
Yeah.
Last one. Here we go, Moreno. How about the probability
But as
of S, of soccer?
that's only, or
Just S, soccer.
so
So what would it be? Thank you. What would it be?
that should be the middle right side of the middle.
No, it's the right side.
The right one.
Shade in the
No,
right
it's the right
side.
side and the middle because you says as.
The right side and the middle?
No, it's not because it's for S only. So
Does it say S only?
No, it does not say S only. If you're at like soccer.
It just says soccer.
For the whole circle.
What circle?
The right circle.
Give me that.
Yeah, that's right.
Watch this. If it said only, watch this. Let me talk. If it said only, I would do this part without the middle. But this is just soccer, so that includes those who like football and soccer right here. So I'm going to shade in the whole right circle. This is soccer here. Everybody in here is soccer. Like soccer. Notice the logic of what we're doing here. This is going to be very important for what I'm about to teach. The last two probability equations. Talk to me. If this was a soccer only, then it would be like this. Because these people like soccer and football, huh?
Oh.
Okay?
Like soccer in general.
Just right. Just if you like soccer, you're going to be in that circle. Hold up one thing. Question. Hit it. Top one. Oh. Because that's not football or soccer. The people who don't like football or soccer, so they wouldn't be in either circle.
Not for us.
Got you.
Yeah, I was right.
My bad. Not F or S. My bad. Not F or S.
Hey, what is that for?
What is what for?
For that one?
Yeah, so this is not football or soccer. Sure. Moving right along. Moving right along.
Oh. Oh.
Last note handout for probability. I'm getting kind of sad
Why?
because I don't want to leave probability. I know how much you guys enjoy this.
It seems like the worst thing. It's pretty cool.
Yeah, it's just that.
It's not that hard.
I like it. I like it.
It's annoying sometimes.
It is sometimes. It's annoying. All right, so the first word there on that handout is a compound event. Go ahead and write the definition. Two events. Put the union, that means coming together, the union or intersection of two events. Stay over here. Hold on. The union or intersection of two events. For example, underneath that, just let me make sure this is on here. The union or intersection of two events, for example, with EX, for example, the probability of someone liking soccer or football from our previous examples of the Venn diagrams. Notice the word or now. Up till now, it's been S and something, like independent, dependent events, something happening and something happening. Now the key word is or. When you see the word or, we're in the world of compound events. And I'm going to get into this now. It's the last kind of probability we have to deal with for Math 2 students. Watch this. Overlapping events. Watch this. Overlapping events are two events that have one or more outcomes in common. Here we go. Two events. What are you talking here? Two events that have one or more outcomes in common. Two events that have one or more outcomes in common. Example? Watch this. Example. Rolling. If I rolled a die, just one die, rolling a 6 or, look at the word or now, an even number. Rolling a 6 or an even number. Rolling a 6 or an even number. Let's draw a simple Venn diagram of that at the bottom here, way at the bottom where it says notes. So right here, go to write rolling a 6 or an even number. They put an arrow. Let's come down to the notes section. Let's draw a Venn diagram so you can see what I mean by overlapping. Want to draw a rectangle? Two intersecting circles. The first category is a category of a 6. The second category is an even number. If I rolled a die, one die, how many sides are a 6?
0. 1.
There's one side that's a 6, huh? Good job, Mario. So, what I'm going to do in this circle, I'm going to name the one side that's a 6, namely the 6. Actually, there's actually one side that's a 6. How many sides are even, though?
4.
See, so you got one, you got the 2, you got the 4, and you got the 6. There's actually the 2, the 4, and then the 6. So look at the circle with even numbers. There's 3 of them, 2, 4, and 6. There's 2, 4, and 6. And the circle with the 6, there's only one possible, and it's inside the 6 circle. So this would be an overlapping situation. How about this? How about this? Instead of putting ones, let's just put the numbers. So on a dice, watch this. Look at the sample space I'm making here. I need it quiet, please. No, don't just write this. Just draw the Venn diagram. I'm gonna put the sample space because it's a little more, because it was unclear. I could tell by Munoz's reaction it was unclear the way I described this. Look at. Here's the sample space for one die, right in front of us. 1, 2, 3, 4, 5. So here's 5, and here's 6. Okay. So here's the sample space. This is the possible outcomes if I throw one die. All right, we'll go slow. Here we go. How many of these are 6? Just one. And look at what I'm doing. I'm going to put it in this circle, but I'm going to put it where the two circles overlap because 6 is also an even number. So go ahead and put a 6 right here. This refers to that outcome right there. It's a 6 and it's an even number. It's part of both categories. Now, so that takes care of my left circle. What about the right circle? How many numbers are even? Well, this one, and this one. This one, the 6, is already mentioned. It's already in the right circle, the right category. Now I'm going to mention the 2, and I'm going to mention the 4. Okay, so far so good, Moreno? Notice how this is an overlapping situation because I have things that are shared between both categories. Namely, look at the probability, a 6 or an even number. I'm going to get into more examples right now. Let me define this last one here. Actually, let me go over one more example of overlapping. Let me give another example. Put example 2, overlapping event. Overlapping events. What's the probability of a deck of cards? Did I get a red card or a king? So it's on the note section. What's the probability of me getting a red card or a king? Let's go ahead and draw a Venn diagram. Yeah. So it's example 2. So the two categories here are red cards. I'll put red here. And over here I'll put king. Are there cards that are red and king? Which ones? What cards would be red and king? Exactly. The hearts and the what? Diamond. So the cards that are both red and king, go to write king of hearts. I'll put KH, and a king of diamonds, KD. Okay? That's what I mean by overlapping events. Is when the events, there's some shared aspects between two categories and it goes right in the middle. That's all overlapping means. The last word we're going to define is when they're not overlapping. They're called disjoint or mutually exclusive. So overlapping is when there's stuff that's in the middle that both categories share, and disjoint is when they don't share anything. For instance, let's go ahead and write the definition here. When two events, or just put two events, that have no outcomes in common. Two events that have no outcomes in common. Write that down. This is the last word here. So it's just 3 words. All right. What would be an example of 2 events that don't have anything in common? Watch this. This is example 3 now on the note section. If you have to turn the page over, fine. You've got plenty of room on the other side. So watch this. Example 3. What's the probability of getting a black card or a red card? You're already doing the numbers. My question is this overlapping or is this mutually exclusive? Mutually exclusive. Let's do a quick Venn diagram. Look at my two circles are not going to intersect. Because there's no such card. There is no such card that's both black and red. Black, red cards. There's 13, actually there's 26 black cards. There's 26 cards here. And there's 26 red cards. But there is no such thing as a card being both black and red. So we would call this disjoint. Remember, joint is when things come together. Disjoint events are when there is no overlap. Not that hard. Don't overthink this. It's very simple. So in this classroom, what's the probability of me randomly choosing a male or choosing a female? My question is this. Is that a disjoint? Is that a disjoint or is that overlapping? It's disjoint. The circles don't intersect there. Of me randomly choosing a male or a female, there's no overlap here in this class at least. Okay. You with me? There's no overlap. So that would be another case of disjoint. Watch out. Relax here. All right. Now, last two formulas. I know you guys are waiting for this. Right here where it says core concepts. Next to this formula, go to write overlapping. This is what you use for overlapping. And this one is what you use for disjoint. Go to write that in. There's only two formulas there. And we're done with probability, you guys. Overlapping formula versus disjoint formula. Two different formulas based on two different types of situations. Right, Sedon? Stay with me here. Finish strong. Finish strong. Here we go. Talk to me. Yeah. Oh, right here next to it. It's on your notepad, right? Right? All right. One away. Quick example. Last one. Let's go to example 4. We're not going to use one of these formulas here. We'll write example 4. Let's find, here we go, Burns. Find the probability of a king or a black card. We're actually going to find the probability now. I'm not going to draw a Venn diagram. Actually, let's draw the Venn diagram. And then we'll come to the probability. So we got king here. That's one category. We got a black over here. That's the second category. We're good. We're going to finish this one. We'll go to the break. So, second stamp here. Pay attention. Make sure you pay notes. Finish strong here. Hold on. Exactly. So, the middle here would be those king cards that are both king and black, and there's two of them. It's a king of clubs, I'll put KC, and a king of spades. Two of them. Right here would be the king of what here? There's two more kings that are not black. Which ones would they be? King of what? King of diamonds and a king of hearts. Cool. The black cards would be, how many black cards would be left over here? How many? Why 24? 2 kings. There's 26 black cards, all the spades, all the clubs. So just put 24 cards here. That's all the rest. There's 24 cards there. Now, watch this. This is overlapping events. So look at what I'm going to use. I'm going to use this formula right here. It looks nasty. It looks a lot more scary than it actually is. Bear with me. I finish strong here. Here we go. You guys are doing good. You guys are doing good. I'll use Dodger Blue since they're going to win again, right, Modio? Here we go. Leave me alone. Watch this. A or B. Instead of A or B, I got king or black. So I'm going to follow right here this formula. Let me talk, gentlemen. Here we go. Okay, so the probability of king or black, here we go. Write it with me. The probability of king or black will equal to the probability of a king, whatever that is. Is that a times or a plus? Let's see. Oh, it's a plus. Look at that. Not times anymore. Look at plus the probability of a black. And now watch this. There's something funky here. Minus the probability of those kings that are black. The cards that are both king and black. Look at this. King and black cards are going to be that one. All I did is I followed this formula on your note guide right here. Because it's an overlapping situation. Yeah. See if you're listening. Right, so let's do it and then we'll go to break. Here we go. Let's do this and we'll go to break. Thanks for criticizing me. Here we go.
Can you do the water too?
Excuse me?
The water.
I got you. Can you do the notes? Yeah, the man burns. What's the probability of getting a king out of a deck? Thank you. Watch this. 4 out of 52 is the probability of getting a king. Plus, probability of getting a black. 26 out of 52. Put that there. Minus now. Watch this. The probability of getting a king and a black. How many cards are there? Let's see. Let's look at the Venn diagram. There's 2 of them right there. 2 out of what? We're rocking and rolling. Look at that. Well, let's simplify now. Just leave it all nasty. Oh. Remember middle school and elementary? You guys dealt with adding and subtracting fractions with the same denominator? All you got to do is deal with the numerator. Look at it. 4 plus 26 is 30. 30 minus 2, 28. So 28 50 seconds. My calculator. Less than the talent for me, so man. 28 divided by 52. 0.54. I run in nearest hundredth. We're rocking and rolling. It'll occur about half the time. Stamp sheets out. I'm gonna come around and stamp you. Second stamp before you go to break.